All right, so we're about halfway through chapter 7. We've talked about constructors, we've talked about overloading. We're going to come back to the idea of doing a dot equals method. We're also going to do a toString method. Dot equals compares two objects, and we did it one way, and now we're going to do it a little bit so-called better. Dot equals is supposed to accept data of any type. I want to compare my car to an apple. I should be able to pass in that apple into dot equals. Now to me, I don't see that that's necessary, but according to textbook implementations of it, you're supposed to be able to do that and then just immediately return false if it's not of the correct type. That's what you're supposed to do. So I am going to give a demonstration of that. I believe we're on Lecture F. A poor Monday, Wednesday class is 2 lectures behind now because of the snow day. Alright, so I think I've mentioned this in the past, but I really would prefer it if we didn't have the package statement, and it's easy to do. You just delete it and then fix the error that pops up, which says incorrect package, move class to correct folder. The only reason why is if we do that, I can copy and paste this into a text editor and compile it without having to have the entire correct directory structure. And I could always delete that myself, but it's just kind of nice. Okay, so kind of guidelines. We've already talked about these, right? Data private, members public, getter setters, right? Constructors, if it helps make it easy to use. Dot equals, if you need to compare them, and toString. And a copy method. Really, we want to do all of these, and I think we've done most of them this semester. I want to make sure we get them all while I am thinking about it. So, just to make it super duper easy, we're going to use the world's easiest class, like a circle class, right? Because it's only got one value in it. So, class circle. Going to have one member. What is wrong with my keyboard? Or my fingers? One member, a radius. I want to get her in a setter for it. I'm going to totally be lazy and let refactor encapsulate fields do it. Cannot refactor because it's not in its own file. I'm sure that's why. Alright, fine. Doesn't take that long. Void set radius, double radius, end parentheses. This dot radius equals radius, semicolon, end curly brace. And if I wanted to make it chainable, right, I would make it return, you know, this reference, but I'm not gonna. And then the get radius needs to return a double, since that's what radius is. Get radius doesn't need to accept anything. And so return this dot radius. Maybe Shannon told me she wasn't going to be here today. All right, like that. All right, so we should make this private, and we should make these public. The default for these, in C++, the default is private, if I didn't put any keyword there. In Java, the default is something almost public. It's public to everything in the same package, but it's not public everywhere. So I'm just going to make it public. So if we use this from an entirely different package, it'd still work. Packages group, just a way of grouping things up into different directories. Alrighty. Now, dot equals just needs to compare this circle to another one. And I'm going to write it the easy way, I guess. I mentioned that the more correct way is to write it so that it'll accept an object of any kind. I'd almost rather just write it in such a way that it can't accept any kind of data other than the correct one, so I wouldn't be tempted to try to compare something to something else. So, kind of waffling on that, but if you compare two things, it needs to return true or false. So public Boolean equals. And what are we comparing? We're comparing another circle to this. So circle other. And then we just start checking. First thing I'm going to do is make sure they didn't give us a null. If other equals null, return false. How about returning? How about not putting an F there? Alrighty. And then let's check the radius. If other dot radius equals or not equals this dot radius, return false. And if we get down here to the bottom and none of those other checks have failed, return true. The if statement is redundant. Says who? No, it's not. I don't see why it's redundant, so I'm not going to bother with it. So what the most proper way of implementing dot equals is to instead make that an object and then to cast this to be a circle, because an object is a generic type. Everything inherits from object. I think I'm going to leave that alone again until we've started talking about inheritance. So why not just leave that alone? That is really bugging me. But I'm going to leave it alone. Okay, so we could create two circles and we could see if they're equal to each other or not. Now I know that I'm going to need java.util.asterisk, right? So why not go and add that to the top? Import java.util.asterisk, just so I get the scanner and everything. Oh, I see why they're maybe saying that, because I could just return. Don't type this. I could just return that, and it would serve the same purpose. But come on, what if I was going to come back and make more comparisons, right? I then have to edit it to make it there, right? Okay. Shut up, NetBeans. Stop warning me about that. So I can make two circles and compare them. Circle C1 equals new circle, parentheses in parentheses, and set the radius. Now, should we have added a constructor? Yeah, I think so. We didn't. Let's go ahead and do so. So constructor has the same name as the class, but it has no return type, not even void. So what's the name of the class? Circle. Public circle. And whatever kind of data you want to pass in, unless you're making a default constructor, you put between the parentheses. Here's our parameter variable, double radius. So this dot radius equals radius. That way down here in main, when we create them, we can just, create them and set the radius in one fell swoop, in one statement. So here's a radius of 10. Let's make another circle with the same radius. If circle C2 equals circle C2 equals new circle, parentheses 10. And by the way, I thought of something else I want to add to my equals method. What if this is the same circle? What if we are comparing ourselves to ourselves? Let's return true under that extraordinary circumstance. If the programmer was dumb enough to try to compare ourselves to ourselves, we automatically know we are the same. So let's add a check. If other equals this, if the other pointer equals this pointer, we try to compare against ourselves. Are we the same address? And then the next line is the address null? Bless you.
Excuse me.
So let's compare these things and see if they are the same, right? So if, parentheses, C1 dot equals, parentheses, C2, in parentheses, then just print they're the same. Or how's about we just do this? Delete all that. System dot out dot println print C1 equals C2 question mark, space, end quote, plus, and then let's compare them right then and there, right? C1 dot equals C2. In parentheses, semicolon. When we run it, it should say true. Now, my wife, who was trained in procedural programming rather than object-oriented programming, this absolutely drove her crazy that all we really need is a radius, right? We could ask for the radius and we could, calculate the area and the volume, and we could do that like in 4 lines of code. And instead, we're going absolutely nuts creating 30 or 40 lines of code in order to do object-oriented programming. And so it just looked absolutely insane to her. It may look absolutely insane to you. But the goal is to teach you how to do this for more complex data than just a single variable. If your data is just, if all you're toting around is a single 8-byte data type, developing in a class like this may be dramatic overkill. But we're learning, right? Just like you have to learn how to walk before you learn how to run down the soccer field. Alrighty, let's run it and see if they are equal. And they are, right? But if we change it, I forgot to call my lecture F. Oh well. Is that easy to fix? Indeed it is. I just highlight that, refactor, rename. My project is still going to be called Java Application 6, but at least I can get this to be called Lecture F like I want. All right, now it's in the correct. Okay, let's change one of these to 11 to make sure that they're no longer considered equal. All right, false. Well and good. Since we have a constructor, we're going to get all fancy and add a count that tells us how many circles we have made. Now that count needs to be a static variable because it needs to not be attached to any instance, right? We want to be able to reference it even if we haven't created any circles. We want to be able to print out that there were 0 circles created. So static int count equals 0. You know what? I'm going to skip this. I'm not going to bother. Well, why not? Why not put it in there and just not do anything with it? Right. Okay. And then this dot count plus plus. I'm going to come back and hit that topic at a later time. Hit it much harder. Nothing wrong with seeing it right now. Why are you giving me a warning? Accessing static field count. Well, that is true. That is true. If this is a static variable, we don't need the this reference to access it, because count is shared among all circles, not just this circle. So I'm getting rid of that. Okay. we're not going to even really talk about what this is, except to say that this variable, since it is static, applies to all circles, not just any particular circle. And I can prove that by making it public and then printing it out after we've created 2 circles, and we would see that we have created 2 circles. All right, we've added equals. We haven't added copy yet, and we haven't added toString. What is copy going to do? Well, what if we wanted to make a circle that was a copy of the other one? Here's how you don't do it. I can't do this. I can't do circle C3 equals C2. Looks good, won't work. Instead, this just points them to the same address. And so if I set the address of C3 to 10, if I set the radius of C3 to 10, then C2 is also going to be pointing to the same data, and it's going to think its radius is 10. And we can prove that to ourselves. C3 dot set radius with a capital R, if you did it that way, parentheses 10 in parentheses. Now it's going to say they're equal again. So by changing C3's radius value, we really change C2's radius value because they're both pointing to the same thing. And I know I've said this before. If you have two signs pointing to the same house, so what? You have two signs that are pointing to the same house. That's what we've got here. The address to that object is stored in both of these variables. What if we wanted to make a circle? Well, sure, we could make a new circle, set its radius equal to the other one. That wouldn't be too hard since it's a single data object, right? There's only one piece of data in the class. But what if there were 20 pieces of data in the class? I would not want to create a new circle and then have to set all 20 of those values in my main code. Close that, that's confusing me. So instead we're going to add a copy method. So here, why don't we do this? End class circle, just because it's almost getting to the point where our class is so long that it's kind of hard to tell where one class ends and the other begins. Now, since this is building a circle to copy, it has to be declarative type copy. So, or we could make a copy constructor that accepted another circle as itself. But I said I was going to call it a copy. So why don't I just do that? Public, capital C, circle. This is also known in a way as a factory method. A factory method is something that builds an object of that class, and you can call it rather than a constructor. And this takes a circle called other. So let's make a new circle. Circle C. No, it doesn't. I botched this. I'm so sorry. I started to make it a constructor, just like I said I wasn't going to do. Public circle copy, and it doesn't take any parameters. And so circle C equals new circle zero in parentheses, and then C dot set radius equal to this dot radius. You see what we're doing? And then return C. So now we can copy the circle. We'll go back down and modify our code so that C3 is an actual copy of C2. If we were awesome programmers, we'd be adding comments to each one of these. Compare two circles. Create another circle from this one. If we had more than one value, like if it was a square and had two, a rectangle and it had two values, we'd have to set both of those values. If it had 20 values, we'd have to set all 20 values. So what's the point of making this rather than just creating a new circle and then setting the radius down in main? Because now we can go add data values, add data members to this class, modify the copy method, and it's boom, it's already fixed. I don't have to go through and find every occurrence of where I was making a copy down in main and everywhere else and adding that second variable. I only would have to fix it in one place. Same with dot equals. We could just check to see if C1 dot radius equals C2 dot radius. We could do that down in main. But what if we started adding other members to it and we needed to compare those as well? And what if we compared circles 20 times in our code? We'd have to go and fix all 20 of those. Whereas here, we just fix it once. All right, let's make a new circle. Copy. C3 equals C2 dot copy, parentheses in parentheses. Now let's change C3's radius again and see if it modifies the value of C2's radius. So C3 dot set radius, set it to 0. We'll just prove right off that it's not. That C2 is going to remain the same. So if we print out C2's radius, or we print out all three objects' radius, let's do that. System.out.printf C1% F, C2% F, C3% F, \n. We have three placeholders. Remember that if you're going to use placeholders, you have to use printf rather than print or println, unlike Python. And so after our quote, we need to fill in those three things. C1.getRadius, open parentheses, close parentheses, comma. C2.getRadius, open close, comma. C3.getRadius, open close. And now we're going to run it, and we're going to find out what their radiuses are. We're going to see if R3's radius is equal to R2. And they better not be, because now C3 is its own object. So when we changed its radius, it didn't change it for 2, unlike up here where it did. All right, 10, 10, and 0. That's what we expected. Let's add a comment here. Since C3 and C2 are references to the same object, changing the radius via C3 also changes it for C2. And then since C3 is a copy of C2 and a separate object, changing its radius doesn't change C2's radius. That's why you use a copy method if you're going to be copying objects, right? And lastly, toString. It would have been nice if I could just have done this. System.out.println C1 plus C2 plus C3. How about if I start the conversion to a string by starting it with a string here? This doesn't work because these aren't strings, but if you concatenate these values to a string, it does work. So how about we do this? Circles equals end quote plus, okay. It'd be nice if we could do that, but right now it's not going to work. It's not a syntax error, but when we print it, it just prints out these references, right? The class type, and then this hashed reference value. If we hadn't created a new object, we'd see that the second and third reference were the same, I believe. Like if we hadn't done that, I'm just going to temporarily comment that out and run it. And I will see that they're the same, right? Both C2 and C3 are the same object. They have the same reference. I'm going to undo that because that completely undoes the concept I was trying. But I want these to actually print information about the circle. I want to be able to print out C1 and have it print good information, not just the name of the class and a hexadecimal reference. And for that I need toString. So let's add one more method. Public capital S string toString lowercase t uppercase s, and let's build our string and then return it. So string s, just to build it, equals string.format parentheses quote, and for some reason I like doing it like this. Put a question mark inside the quotes and say circle radius equals %f close parentheses. And then after our end quote, we need to fill that value in. So string.format does the same thing as printf, except it just builds a string rather than printing it to the screen. So after my comma here, before my closing parentheses, I'm going to print out this dot radius in parentheses semicolon. If I had more pieces of data, right, I could print them out. I could add in more placeholders. You know, this dot height, this dot rate, you know, depth, whatever. You know, I just add a couple more %fs to handle it. And then we return our string. Alrighty. And see, when we printed out our circle, we see that we have a circle that's a 10, we have a circle that's a 10, and we have a circle that's a 0. Let's go back and retroactively add one more member to our class, which is a name, so that we could give each circle a name, so that when we printed it out, we saw its name. And then we'll be done with this great big example. So, I need a new instance member, private, capital S, string, name, semicolon. My constructor, I didn't label it, but I'm going to label it now. My constructor, right there, needs to also accept the name. So I'm going to modify this line as well. I just added that. Modifying this. So string moving it to here after radius. String capital S name, but I'm going to give it a default value. If we don't specify this value, that's too complicated. Forget that. Remove the default value. And then set this dot circle, this dot name equal to the name that's passed in. This dot name equals name. Now what else do we need to change? We need to change our dot equals method, we need to change our copy method, and our toString method. We have 3 things we need to change. And by the way, this introduced an error because our constructor now requires more arguments, right? Because we have an additional parameter here. Okay, so we had to change equals. Let's do that. If this, if, this dot name dot equals other dot name, return false. But really, we want it to return false if they're not equal. So I'm going to insert a not symbol in front of that expression. If not, this name dot equals other dot name. Or I could have added equal equal false to the end of this. All right. All right, we've done that one. All right, now we need to modify this constructor because the constructor accepts a parameter. You know what we could do is instead of doing this, we could just pass in this dot radius while we're creating it. See, if I'd added a default constructor back again, then I could create it like that without setting any data whatsoever. I'm going to delete this. I'm like, no, I am. I'm going to delete that line and just pass in the information we need, which is this dot radius, comma, this dot name. I'm going to add a comment. We could have used c dot set radius and set name to set the values of the new circle, or of the copy circle. One last thing to change. We've done equals, we've done the constructor, we've done the copy, and here. Let's add the name as something we want to print out, right? So in front of radius, why don't we put name equals %s, right? So I'm on the toString method now. I just added name equals %s right here, and we better fill in that placeholder with the actual value, this dot name, comma. And you saw what I did is I just hit enter on this dot radius, right, to move all the parameters onto the next line. All the arguments to fill in those placeholders. All right, now when we run it, not going to work because we have some constructors that are expecting a name value. Right? So, what's the name of this circle? C1. What's the name of this circle? C2. Now C3 is a copy of C2. So it's going to have the same name, even though it's a different object. Realistically, we should probably set its name after we've created it. So C3 dot set name. Oh, I forgot to add a setter for it. I'm going to ignore doing that. Okay. So now when I run it, right, we have one circle called C1, we have a second circle called C2, and a third circle also called C2. It's bugging me, isn't it? Yeah, it's bugging me. Am I going to go and add getters and setters for it? Yeah, of course I am. Let's go do that, and then we'll be done with that particular class. So here's what we're going to do is we're going to come up here, find our getters and setters. Public void set capital N name, parentheses, capital S string name, in parentheses, this dot name equals name, semicolon, close brace. Do you have to use this syntax where you put everything on the same line? No, but getters and setters are so simple that I like to try to make them just take up one line. It's a non-standard way of doing it. Now we need to be able to get the value, and since name is a what is the type of the name? It's string. So public string get name, parentheses in parentheses, open brace, return this dot name. Conceivably, we can make that copy method to where it could set a new name at the same time, but then it's not really a copy anymore, is it? Alrighty. So here's our class so far. I'm just going to scroll down slowly in case you've been typing it in and you've got a syntax error. Alright, so here's all of the opening stuff, including the constructor, the dot equals method, the copy method, and the toString method. Alright, now down here, after we make our copy, we're going to set both its radius and its name. So C3 dot set name, C3 is his name. Alright, and there we go. Circle C1, 10. Circle C2, 10. Circle C3, 0. Okay. That is a fairly robust class. Meaning that for anything that I can think of that I'm likely to use it for in the near future, which is probably very little, it's fully implemented as far as I'm concerned. Got all this. constructors equals toString and copy. Wait, I lied. That should not say members private, right? What should that say? If the members are private, can we even call them? And why did I call them members? Methods. And what should our methods be set to? Yeah, they need to be public so they can be called, right? And then we need getters and setters, and then constructors if it makes it easier to use, constructors if helpful, and then equals and toString and copy if you think you're going to be comparing objects or printing them out or making copies of them. So again, those are if helpful, if helpful, if helpful. All right. Anybody need help? Y'all are too good at typing, I swear. So instance constant. If you're going to make some kind of constant, and I don't know what we would make here, but we could, like a class name constant. You do final string class name equals quote circle. Now why final? Because it's not supposed to change. That's what makes it a constant. Since it can't change, why not make it public? But let's see if the slide has any more recommendations about that than what I just said. Public final string name. See, they made their constant public, so you could just access it without using a getter. I guess if it can't change, why not make it public? So public final string class name equals circle. So if we wanted to print it out, we could do so. And if it applies to all circles, we could make it static. I could type in public static final string. We're getting a lot of keywords there. I'm just going to leave that alone. But recommendation, according to the book, constants in the class should be defined as final. Make them public if it's useful to be able to access them from the client code, from the driver code, client driver code. In other words, from main. It is legal to assign a value to an instant constant only once. I could have waited to assign that value inside the constructor. Their example makes name a constant, meaning that we could not have changed the name C2 to C3. Instead, we made the class name a constant, but since it is assigned here, I could not reassign it later. I could not do this class name equals quote circle. I don't know why I made it caps, whatever. If I wanted that to work, I'd have to delete it here. Which do I like better? I don't know. How about leave it that? All right. You can assign a value to a constant member either in the constructor or when declared. If it's a static variable, you'd have to do it when it was declared, because it'd need to have a value even if no objects have been created. And that's the point of a static variable, is so that you can access it even if no objects have been created. So because the final modifier keeps the constant from being changed after it's initialized, it's safe to go ahead and make it public. So class variable. Now we're starting to talk about static variables. Based on what you've learned so far, when you're working on an object-oriented program, each object has its own set of data, right? So I have my own, DNA, and Charles over in the next room has a different DNA, right? I have a different birth date, different age, different height, different weight. That's a valid picture, but you should be aware that in addition to data and behaviors that are specific to individual objects, you can have data and behaviors that relate to the entire class. Like every student here is a member of Rose State. So we could make a variable called school and just set it to Rose State, and it would apply to every object we create. Now honestly, when we're talking about static members, I struggle to come up with examples. The best one that I've ever found is the counter. So since they relate to the entire class, such data and behavior are referred to as class variables and class methods. So these are the ones that are declared as static. So this is an instance member. It's non-static, which is not a technical term. There's no keyword called non-static. And this is a class member, meaning that it's shared by all objects. And it's not even shared by all objects, it's stored outside of them. It applies to the class, not to any specific object, because we could access the count of objects even before a single object is created, in which case it'd be 0, right? So a class member is not a part of any particular instance. It is accessible via the class name and not an instance reference. So I don't have to access the count by saying c1.count, c2.count, c3.count. Instead, I just say circle.count. It's the closest thing that this language has to global variables if you've used global variables in C++ and Python, because it exists outside of any object. And it is initialized as soon as the application loads. So class members are static, so I'm going to go ahead and put that in my notes. Alrighty. So I made the counter public, which I probably shouldn't do, but I did. I should encapsulate it. Why? Because I don't want somebody else to come in and sneak in and change my count of my circles, to 27 when that's not true. But I'm not gonna, and I'm gonna come down here to the bottom of all of our print statements and say system.out.printf parentheses, quote, circles created so far equals %d \n, end quote, comma, circle.count, end parentheses, semicolon, right? So you see that I didn't address it as c1.count, c2.count, c3.count. If it is legal, and I believe it is, it's going to warn me about it, saying that's stupid, right? Because I would not want to be counting the number of C1s. But it's a way of addressing it, but I should address it by its class name, because that's what it's really applicable to. It's a class variable. So when we run it, it should say that we've created 3 circles, because as a matter of fact, we have. Sometimes when you write code, you'll find out that more objects are being created than you really expected. And that's because some member is creating a circle and you're not expecting it. I can't really explain why, but here we go. That's far more true in C++. Circles created so far is 3. That's very true. Copy that line and whoopsie and paste it above all of our printfs. And we'll see that circle created is 0 at that point, right? So just copy that line and paste it at the very beginning of main. Now you see why it's a class variable, right? Not an instance variable. C1.count doesn't work because we haven't created a C1 yet. And honestly, the class name ought to be made static as well for the same purpose, so I could get the name of the class out. And it's bugging me that it's not. Let's go ahead and go back up and change it so that it is. Find this public final and make it static. Public final static string class name. And I wonder if that's going to break it. Yeah. Since we're doing it that way, we shouldn't be setting it in the constructor because the class name won't have ever been set until an object is created. So we're just going to initialize it right here, changing my mind on that. So I've changed this line. I've made it static so that it's accessible via the class name rather than any particular object name. And I need to find my constructor. My constructor is, getting pushed. Where is it? There he is. Usually I put my constructor right up at the top underneath the variables. And so I'm going to take that out. Once you've assigned a final variable, you can't assign it in again in any methods. So down here we could print out the name of the class, right? System.out.printf parentheses quote class name equals %s \n end quote comma capital C circle dot class name. Now if I was going to get inanely complicated, I would go in and modify my toString to use the class name variable to fill that in. No need for that. It's already pretty excessive. You certainly don't have to add a count variable to every class you make. You certainly don't have to add a class name variable for every class that you make. Really, really, really you don't have to. These are just examples. Counters are really about the only thing that I've ever come up with is making static other than constants. Constants and counters, because they apply to the class as a whole. Like if you have a file class, you might want some constant that indicates the maximum number of files you could open. And then you might have a static counter which indicates how many files are open at this time. Alright, so the class name is circle. We have created 0 circles at that point, and then we've turned around and we've created 3 at that point. So every object has its own copy of the instance variables. And yeah, they could have the same values, just like you could have 2 people named Jeff. But they're still applicable to that specific instance. Each person has a name Jeff, and if I go and legally file my, file legal paperwork to change my name to Joe, I can do that. But each of the class's objects shares a single copy of the class's class variables, its static variables. So if you'd like a variable to be shared by all objects, you just use the static keyword. For example, they're talking about making an average lifespan and a count, just like I did. So scope. We've talked about scope. Scope is where you can access the data. These variables in this class can be accessed within any of the methods in that class, right? The constructor can get a hold of, radius and name and count and class name and print them out or whatever. But if we create a variable in the constructor, int x equals 3, don't do that because it's dumb. But that's a local variable, right? It's only accessible inside this method. I couldn't print x out here. Its scope is limited to between these two braces. These guys here are not limited to just within these two braces because they're public, right? And so anything can get a hold of them. They're kind of the exception. Public static variables especially are the essentially global variables that can be accessed anywhere. Any other variable is only valid inside the braces in which they're defined. If you define something inside, like if 1 is equal to 1, and then put a variable in here, int y equals 7, I'm not going to be able to access that y at this point. Y is gone at this point. Garbage collector comes and removes the memory that was dedicated for it. Just like these circles. This is the end of main. If I had another method down here, they would not be able to get a hold of these circles because these circles are part of main. Now say you really wanted multiple methods to be able to access those circles. If that was true, you would declare them outside all of the methods. I could declare a circle out here, and then all of the methods in this class would be able to access it if I made it static. Why do I say that? Because this is a static method. If it's going to get a hold of a variable, that variable also has to be static. I don't particularly see any need to do that. I did see a user, a student, and I don't remember if it was in Advanced Java or Intro, making their variables that they used inside main declared up here, even though they didn't have multiple methods. I wouldn't do that. If a variable is only going to be used inside main, declare it in main. Make it a local variable. A local variable is one that's declared in main. I mean inside that method. All of this stuff are local variables. So class variables have a broader scope than instance variables. Local variables have narrower scope. They're only accessible inside that method. So if that data needs to be used anywhere else, you can return it with a return statement, or you can pass it into another method as an argument. Narrower scope equates to more encapsulation. Our private members are very protected from the client code, the driver code. Their scope is completely restricted to that class. You should prefer local variables over instance variables, and instance variables over class variables. Well, since it's hard to even come up with reasons for class variables, I'd certainly agree with that. But constants and counters, they could be class variables. And class methods are the same way. If I wanted to get a hold of that counter and I wanted to write an accessor for it, I could write a getCount method, right? And if I was going to do that, I'd want to make it static so that I could call circle.getCount. I would not want to have to create a brand new circle just to find out how many I'd already created. That would change the data while I'm getting it. Kind of like the Heisenberg uncertainty principle if you've done physics. If you access it to try to measure it, you're actually going to change its position. So if you access a class member, you do it by the class name. So if the thing in front of the dot has a capital letter, you pretty much know it's a static variable or method. When to use class methods? We've kind of already talked about this. If you use a method that has class variables or calls, it's a good candidate for being a class method. Yeah, no, don't know if I agree with that. Main has to be a class method. Why does main have to be a class method? Every time we make it a new class, this comes up as a class method, a static. The reason for that is a Java virtual machine does not want to have to create a brand new object just to call main. And that would be the case if it was declared as non-static. It would compile, but Java would not be able to run it. it wouldn't find that hook in order to launch our application. It says no main class is found. About time to roll to a stop. Class constants can be declared as static. Why not? If the constant is to be used only within the class, you can make it private. Quiz questions. What does Java's garbage collector do? It searches for inaccessible objects and converts them to free space. What does that mean? Once I get out of main, I have all these circles that were allocated. They don't need to be hanging out anymore. The garbage collector will come and clean them up. Same for any local variables. In fact, all of these are local variables, so once that method is done, they're gone. Here, this is a local variable, but it gets returned. So its space is not really gone. But when this one exits, then it will be gone, and the garbage collector has to clean it up. If we just had int x here for some reason, right, then once we leave this method, x needs to be disposed of. And there's no way for us to call the garbage collector. The garbage collector does it on its own sweet time. So rarely is that important. I believe you can ask the garbage collector to run. Try to nudge it to run more quickly. I think. So overloaded methods are objects that have more parameters than the maximum number of parameters allowed. They share memory space with tendril instance variables. What the heck is that? It's a good thing this is a quiz question because that does not make any sense. What is an overloaded method really? It's one that has the same name and different parameters. We've talked about that. You can create multiple constructors. A constructor is called whenever a Boolean variable is used? No, that's silly. When an object is instantiated with a new keyword, that's absolutely correct. That's the correct answer. And class variables use which of these? Somebody tell me. We've said it 20 times today. Yeah, static. All right. Am I going to make you all add a toString and a copy? Have we already done an assignment like that where we did that to our book class?
Oh, we copied the book class? I don't think we've copied it.
We did the dot equals.
We've done everything
So we've
else.
done dot equals as part of new improved. We've added an equals method to it. Nah, let's not bother with the copy. All right. But I did assign homework this week, right? We have homework 4 assigned early. Okay. All right. So one homework assignment's enough for this week.
And are you going to open quiz 6?
It's not open? Sure will. And 7.
I know we just said
And 7.
7.
Yep, and 7. Right. Okay. They'll both be open. Thank you for reminding me. All right, gang. Why don't we stop here?